All right, good morning, guys. Sorry I am not there. I am not feeling fantastic. So I'm going to go over the last example that's in our notes and then do another kind of real world example with these writing sinusoidal equations. Excuse me. So our last example, here we go. So we want to write a sinusoidal equation for the graph with an amplitude of 5. Period of pi over 8. And through 4/9. Alright, so first let's kind of see what that might look like. Remember, this is just kind of a rough sketch. It's not perfect. I'm not concerned about graphing everything perfectly. I'm just trying to get an idea of what things look like so I can label it up and I can find all my values. So, come on, there we go. Maybe this is 4/9 right here. And then down here we'll have our other point. So it's going to go something like this. All right. So right through the middle of that wave right here is going to be our midline. And the distance between our point and our midline should be our amplitude. So our amplitude right here is going to be 5, as it told me earlier up here. So if this point is at 9 and I've got an amplitude of 5, that means I'm going to have y equals 4 right here. So what I've got so far is that a is equal to 5. We can find b real quick. Remember, that's going to be 2 pi over b equals our period, so pi over 8. You can do whatever makes you feel good to solve this proportion. I'm a cross multiplication kind of girl, so b is going to be equal to 16. Make sure to simplify those, guys. When I was going through and grading quizzes, I had a lot of like 4 pi over 2 and stuff like that. Make sure you simplify. Don't leave the pi's in there. Okay, so we've got b. We don't know what c is going to be. We're going to have to find that out using the point. But we know d is going to be 4. So we're going to take all of these pieces of information and that point of 4/9. We're going to find our equation. All right. So I've got y equals a cosine. Oh, I can put in something for a. Oops. 5 cosine of 16x plus c plus 4. So then I had that point of 4/9. So I can put that 9 in for my y. And I can put that 4 in for my x. And start solving. So I can subtract 4 from both sides, so I'll have 5 equals 5. Cosine of 16 times 4 is 64 plus c. Divide by 5 on both sides. So 1 equals the cosine of 64 plus c. To get rid of that cosine, I'm going to have to do the inverse cosine or the arc cosine. A lot of this is going to be no calculator on your test. And there are some people that immediately jump to, oh, let me put the inverse cosine of 1 in my calculator. Please don't do that. Especially when it gets to something different. I'll talk to you about that in a minute. Anyways, so my inverse cosine at 1. So where is my cosine 1? This could either be 2 pi or it could be 0, right? So let's do 2 different ones. So maybe I'm going to have 2 pi equals 64 plus c and 0 equals 64 plus c. So I have 2 pi minus 64 equals c, or I just have negative 64 equals c. So remember, I've been trying to make a point about this, but some people seem to just keep being concerned because they're not getting the exact same answer as me, or they're wanting to do it a different way, or why does it have to be a maximum? Why can't it be a minimum? Why can't that point be at the midline? It totally can. That's fine. You just gotta go through and make sure that you figure everything out, as long as it fulfills all the conditions at the beginning, I'm happy. So, here's one value for c that I have right here. So I could rewrite this as y equals 5 cosine of 16x or theta plus 2 pi minus 64 plus 4. That would be a perfectly valid, beautiful answer. If you wanted to use just negative 64, you could do that too. So you could have y equals 5 cosine of 16x minus 64 plus 4. Both of these are completely valid answers that totally fulfill all of the conditions given in the problem. If you wanted to go through and solve this as a sine, go for it. Whatever makes you happy. If you just want to mix it up and do something different because you just get sick of doing the same process over and over and over, that's totally fine. Go, have fun. Just double check that it does fulfill all of those conditions. Okay, so I've got a real world one for you. And it's a little bit punny. So here, let me see if I can share this over real quick. There it is. All right, here we go. So, example 3 on this one. On February 10th of 1990, I think I was 5 months old. You weren't alive yet, so, Anyways, February 10th, 1990 was high tide in Boston at midnight. The water level at high tide is 9.9 feet. Later, at low tide, it was 1/10 of a foot. Assuming the next high tide is exactly 12 hours later, and the height of the water is given by the sine or a cosine curve, find the formula of the water level in Boston as a function of time. So, we're going to keep doing the same thing. What we have right here is we have that 9.9 feet. Since it's high tide, that is going to have to be a maximum. Low tide, this 1/10 of a foot, that's going to have to be my minimum. If I'm going to end up at high tide again in exactly 12 hours, that 12 hours is going to be my period. So I've got a period, I've got a maximum, I've got a minimum, so I can go ahead and solve this guy out. So you can do this in whatever way makes you happy. Remember, it said a sine or a cosine curve. What the heck, maybe we can do both. You can stop me if you're just like, ugh, I don't care. That's fine, but I'll do both. So I've got a maximum at 9.9 feet, and that's just kind of at midnight, right? So we'll just call that kind of 0. So maybe 0, 9.9. And then I have a minimum that's happening at a 1/10. And then I'll have a maximum again after 12 hours. We back up at 9.9. Alright, so this graph right now looks something like, oopsies, does not look something like that. There we go. Okay. So now this point right here with our 1/10, if it's going to take us from 0 to 12 to go through one whole period, this minimum must be at 6. Not that it matters all that much, but I'm just throwing this out to you. Alright, so over here we're going to have our midline. So we're going to have to figure out, what this amplitude right here is going to be. So the way we figure that guy out is we're going to take that 9.9, we're going to subtract that 1/10 from it, and then we're going to divide by 2. So 9.9 minus a 1/10 divided by 2 is going to give us 4.9. So the distance right here is going to be 4.9. Same with this distance right here. Remember, those distances are called our amplitude. So right now we've got A. A is 4.9. Real quick, let's find B. Remember, 2 pi over B, set that equal to the period. Remember, the period is the distance between the minimum, or the distance it takes to go through one full cycle. So from maximum to maximum. For maximum to maximum here is 12 units, or 12 hours. So I'm going to have 12 over 1. Cross multiply that sucker, or however you want to solve it, because you are math competent enough to know what you want to do. Simplify that guy, and we end up with pi over 6. Do not give me 2 pi over 12. You're an honors pre-calc, you can simplify that. I know you can. On an IB test, if you're an IB kiddo, totally, don't simplify it. But otherwise, you know, if we're going on just for the IB test, don't simplify. But otherwise, just for general mathiness from here on out, make sure you simplify. So B is going to be pi over 6. Super. C is what we always have to solve for, so we're not sure what that is. And then real quick, we can also solve to find out what D is. So over here, if I am at 9.9 and I am 4.9 units away, that means that I'm going to be at 5 right here. Beautiful. So y equals 5. So my D value is going to be 5. All right, so we've got our A, B, and C value, and we also have a point, because the 0, 9.9, at time 0, we had the height of our water was 9.9, or the height of the tide. So I'm going to go ahead and use that point to help me out. So I've got this guy, And you know what? Let's go crazy. Let's say that this time we're going to use sine instead of cosine. Let's just pretend for fun. All right, so I also want to pass through the point 0, 9.9. Okay, cool. So here we go. Y equals the sine of 16x. Oh, 16. Where am I getting that? That was the last problem, Mrs. Davis. Pi over 6x. Oh my gosh, I totally forgot to put other things in. Okay, let's just start over. Sorry, there's a reason I'm at home sick. Okay, y equals 4.9 sine. I just got so gosh darn excited about talking about sine. Pi over 6x plus c plus 5. All right. And then we're going to go ahead and plug in our point. Come on. So I've got 9.9 here in for y equals 4.9 sine of pi over 6 times 0 plus c plus 5. So the first thing we're going to do is we're going to subtract 5. Get that 4.9 equals 4.9 sine of c, if we simplify that inside. Divide by 4.1, so we're going to get 1 equals the sine of c. And just like we did with the cosine, we're going to use inverse sine or arc sine here. So the inverse sine of both sides. So I'm going to end up with the inverse sine of 1 is equal to inverse sine and sine. They undo each other. That's what inverse operations do. So I'm just left with c. So now remember, this is asking, where is sine equal to 1? So my sine is 1 at pi over 2. And my sine is 1 at, oh no, it's not 1 at 3 pi over 2. I lied to you. That's negative 1. JK. So pi over 2 is what I'm going to be using for that guy. So then I'll rewrite my equation. Y equals 4.9 sine of pi over 6 x plus pi over 2, oopsies, plus 5. So you have a lot of different options for however you want to write these equations. I'm really happy with whatever you want to go with. So for the rest of class, you're going to finish up those 6 problems that are on Schoology. Whenever you see a P, I've been trying to fix this. I have tried like 6 or 7 different things, and I don't know what's going on. But if you ever see a P and you're like, what the heck is that? And especially if it's talking about a period, that P is usually standing for pi. Not usually, always. So, I'm sorry about that. I don't know why it does that when I turn things into a PDF, but, you know, it'll get figured out. So, hopefully I will see you Monday, because I don't think I'll be feeling great to come back tomorrow. So, I'll see you later. Have a good weekend.